Faru, and then our topic today is probability. Okay, right? Today we'll be looking at the end of today's lesson. You should understand the concept of Venn diagram, tree diagram, and contingency table, and how to solve problems relating to the above mentioned. Okay, right. So Venn diagram, in Venn diagram, we use a circle to represent different events and rectangle to represent the sample space. So when the events are such that they can overlap, when the events are such that they can happen at the same time, then we have the circle overlapping. Okay, and then we say there are intersections between the two events. But when events are such that they cannot happen at the same time, we say they are mutually exclusive, and then the circles don't get overlap. So our rectangle is our sample space. So let's illustrate this question using a Venn diagram. The Sell Move Estate Agency has 31 clients to find suitable properties for. It also has 23 clients whose properties they must sell. The company has 42 clients altogether who fall into one or other of these categories. Draw a Venn diagram and then answer the question. So to draw a Venn diagram, so we use circle events. We use events to represent the different events using letters. So those that want to buy properties, those who want to buy the properties, we represent them with B, and then selling properties, we represent them with event X. So in this situation, we have some group of people who fall into these two categories, those who are buying and those who are selling. So we represent those, first of all, with what X? We represent those with X because now we don't have the numbers who fall between these two categories. So we represent that number with X. So we calculate the value of X, and then from there we can solve other questions we asked. So the question asks us to draw a Venn diagram for the event. So 31 are those who want to buy properties, and the total of those who want to buy properties, and 23 are those at the total for those who want to sell. But among the 31 who want to buy, some of them wants to sell. Among the 23 who wants to sell, some of them wants to buy. So we represent those who wants to buy and those who want to sell with what's X. And then that will be X will be placed at our intersection, this position here. Okay, so with X here, so the balance of this part, this section, 31 minus X. So 31 minus X will be for those, the number of those who only wants to buy. And then to get this other section here, we say 23 minus X. So that we get the balance of those who only want to sell. We have those who only want to sell. We have those who want to buy and sell, and those who want to buy alone. So this one is buy alone, this one is sell alone, this one is buy and sell. And then the total of all the clients is what? 42. So we're saying what? Our sample space is 42. So we have the X here, we have 23 minus X here, we have 31 minus X here. So this, and we have 42 here as our sample space. Then that is our Venn diagram. Okay. So that's our Venn diagram. The question says, how many clients is the company both trying to find a suitable property for and trying to sell for? So how many clients is the company both trying to find a suitable property for and trying to sell for? So how many clients falls into both categories? How many clients fall into both categories, buying and selling properties for? So now that means we should find what the number of X, because X, we said, there are those who represent those who are having both, who are in both events. Okay, so basically we need to calculate our value of X. Okay, so to do that, we understand that by the time we add those who are buying only, plus those who are buying and selling, and those who are selling only, everything have to add up to 42. So we add all this together, 31 minus X plus 23 minus X must give us 42. So when simplify this, X minus X plus X gives us 0, 31 plus 23, then we move the X over to become positive. I'm moving 30, I'm moving 42. So here we're going to have 54. 54 minus 42 will give us what? 12. So our X value equals to 12. That means 12 are those who are both selling and buying. So 12 are those who are the group of people that are buying at the same time selling. Okay. So that answers the first question. And then the next question, and the second question says, what's the probability that one of the clients for whom the company is trying to find a suitable property for is one for whom they are trying to sell a property? Again, what's the probability that one of the clients for whom the company is trying to find a suitable property for is also one for whom they are trying to sell a property for? So what probability of getting someone who is in both groups? To find probability, define probability as number of required outcome over number of possible outcome. So those number is what the actual of such people divided by the total number, and that would be what? 12 over 42, which is simplified into 2 over 7. 6 divided into 12 is 2. 6 divided into 42 is 7. So the probability of getting those who are buying at the same time selling is 2 over 7. Okay, so that's number one example. Let's see another example using the tree diagram. So the tree diagram, example 2. Judy and a friend decide to take a break from studying and go for lunch. Judy goes to a restaurant and has a choice of starter, either a soup or salad. And then a main course which can be either a beef, pork, or chicken. And a dessert which can either be ice cream or truffle. Now, if she is equally likely to choose any option, draw a tree diagram and determine the probability that she will have an ice cream and not a beef. So this here we can use what? A tree diagram to illustrate this. Judy and her friend decide to take a break from studying and go for lunch. Judy goes to a restaurant, so they have three things. They have the starter, they have the main menu, and they have the dessert. For the starter, they have 2 options. For the main menu, they have 3 options, and for the dessert, they have 2 options. So we have to use tree diagram to illustrate these, and then find the probability that they will have what? Ice cream and not beef. So to start with tree diagram, we start off with the first event. The first event being the main course, being the starter, the soup or salad. We start with the start and the starter. The starter can either be soup or it can be a salad. So with the starter, they can either have soup or they have a salad. So now with the main course, so say take that they have soup. So with soup, they can either have soup and beef, chicken, or pork. And then assuming they have salad, they can have salad with what? Beef, chicken, and pork. Okay, so now for the dessert, say they have soup and beef. So with the dessert, they can have what? Either ice cream or truffle. If they have got chicken as in course, yes. Yes, Madeleine, you raise your hand, Madeleine. Any question from Madeleine? Any question for Madeleine? You can ask your question. Okay, Madeleine, you can ask your question on the question chat. Okay, right. So now I'm saying I'm talking about the dessert now. Having beef as the main menu, they can have ice cream or truffle. Having chicken as the main menu, they can have ice cream or truffle. So we're gonna extend the tree. I mean the tree keeps opening up. This is the branch, this is the main stem, these are the branches, and these are the leaves. So it keeps extending like that. So having soup, you can have soup, beef, and ice cream, soup, chicken, and soup, beef, and ice cream, soup, beef, and truffle. So you can have soup, chicken, and ice cream. You can have soup, chicken, and truffle. You can have soup, pork, and ice cream, or soup, pork, and truffle. And then if they want to have salad, they can have salad, beef, and ice cream, salad, beef, and truffle. Or they can have salad, ice cream, and they can have salad, chicken, and ice cream, or have salad, chicken, and truffle. They can also have salad, pork, and ice cream, or salad, pork, and truffle. So these are all the possible outcomes they can have. So the first outcome can be soup, beef, ice cream, soup, beef, truffle, soup, chicken, ice cream, soup, chicken, truffle, soup, pork, ice cream, soup, pork, truffle, salad, beef, ice cream, salad, beef, truffle, salad, chicken, ice cream, salad, chicken, truffle, salad, pork, ice cream, salad, pork, truffle. These are all the possible options. Okay, this is also represented with a tree diagram. Okay. Now, the question now says, the question to answer, the first question is to draw a tree diagram, which we did. Now, if she is equally likely to choose any of the options, draw a tree diagram and determine the probability that she will have an ice cream and not beef. So what probability that she will have an ice cream and not beef? So how do we do that? So out of our total outcome here, these are our outcomes. So how many ice cream do we have? We have how many ice creams? 1, 2, 3, 4, 5, 6. So we have total of ice creams. We want to find the probability that we're going to have ice cream but not beef. So having ice cream, there are 6 options. But without beef, how many do we have without beef? Having ice cream, there are 6, but having ice cream without beef. So this is ice cream with beef. That means doesn't qualify. This is ice cream without beef 1, ice cream without beef 2, ice cream with beef, this is out, ice cream without beef 3, the ice cream without beef 4. So the chances she has of having ice cream without beef is 4 out of a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Out of a total of 12, there are 4 chances of having ice cream without beef. So the probability of having an ice cream without beef will be 4 out of 12. So she has the probability of having ice cream without beef will be 4 out of a total of 12. So our answer there will be 4 over 12. So the tree diagram shows all the options. The blue pathways label the options that satisfy the criteria of the question. Having ice cream without beef is 4 out of 12 options, and that is 3 over 4, and that is 1 over 3. Okay. Right. Let's see another example. A marble is drawn from a bag containing 3 blue, 3 red, and 8 green marbles. A marble is drawn from a bag containing 5 blue, 3 red, and 8 green marbles. A second marble is then drawn without replacing the first. Draw a diagram and determine the probability that 1, the marble drawn will be the same color. 2, the marble drawn will not be green. Again, a marble is drawn from a bag containing 5 marbles and 5 blue marbles, 3 red marbles, and 8 green marbles. A second marble is then drawn without replacing the first one. Draw a tree diagram and determine the probability that the marble drawn will be the same color. How do we do that? So first, we need to draw a tree diagram. So we have in a bag, there are 3 colored marbles. You have blue, you have red, and green. So choosing the first marble, it's possible you choose a blue marble or choose a red marble or a green marble. So what's the probability of choosing a blue marble? You need to find the total number of marbles, which is 16. The total number of marbles is 16. How do we get 16? We add all the marbles. 5 plus 3 is 8. 8 plus 8 is 16. Total marble is 16. Right. So selecting the first marble, what is the probability of selecting the first marble? So selecting the first marble, it's possible you pick up a blue marble, or you pick up a red marble, or a green marble. So what is the probability of choosing a blue marble? It will be 5 out of 16. So there are 5 blue out of a total of 16. Probability of choosing a red marble is 3 out of 16, because there are 3 red out of a total of 16 marbles. And what probability of choosing a green marble is 8 out of 16. That is the first event. For the second event, so choosing blue marble for the first one, for the second one, it could be what? Blue, red, and green as well. So the probability of choosing blue again will now be 4 out of 15. 4 being the number of marbles have reduced. They were 5 because one is taken without replacing the first one. Now we now have what? 4 blue, and then we have a total ball of 15. Probability of choosing a blue again will be 4 over 15. And probability of choosing a red ball will be 3 out of 15 because there are 3 red but 15 balls now before the second ball is chosen. And the probability of choosing a green marble for the second selection will be 8 out of 15 because now the total number is 15. Why? Because the first ball was not replaced. Okay. Now, assuming the first ball that was selected is red, so the chances of selecting a blue ball for the second ball will now be 5 out of 15 because there are 5 balls, 5 blue, and the total is 16. Total balls now is 16. And the chances of selecting red ball again now will now be 2 out of 16 because now the number of balls have reduced because the first one was not replaced. There were 3. The first one was not replaced. Now it's now 2, and the total is 15. So chance of choosing red ball again is 2 out of 15. And then chance of choosing green or above will be 8 out of 15. Now, so taking green as the first marble, the chance of getting a blue marble again will be 5 out of 15, and chance of getting red marble again will be 3 out of 15, and chance of getting green marble will be 7 out of 15. 7 because the number of marbles have been reduced. There were 8 initially, 1 was not replaced, then the total is 15, and then we have 7 green marble left. So the chance of getting green marble again is 7 out of 15. So these are the possible outcomes. So combine them together. You can have blue, blue, you can have blue, red, you can have blue, green, you can have what? Red, blue, you can have red, red, you can have red, green, you can have what? Blue, green, blue, you can have green, red, and then green, green. Okay, now the question says find probability that marble drawn be the same color. Same color marble will mean what? Either it's blue, blue, or red, red, or green, green. That is what satisfies that condition. Again, the question is calculate probability that the two marbles selected are of the same color. But the same color will imply either what? They are both blue, or they are both red, or they are both green. So to do that now, we now have to combine, for blue, blue, we will multiply the two probabilities. So if we're going to say 5 over 16 multiplied by 4 over 15, 5 over 16 over 15, or is plus. In probability, or means plus, and and means times. The word and means times, and the word or means plus. We have 5 over 16 multiplied by 4 over 16, or that means plus red, red, 3 over 16, and what? 2 over 15. So we say 3 over 16 times 2 over 15. Or we can have green, green. Green, green also means what? Same color. When we say same color, it could be, both of them are blue, it can be red, red, or it can be green, green. So you must do the 3 cases and put the 3 cases together with what? Or with addition. So probability of getting green, green is what? The first green is what? 8 over 16. The second green is 5 over 15. If the second green is 7 over 15. So it's going to be 8 over 16 multiplied by 7 over 15. And then we add all this together, we get 41 over 120. So that is probability of selecting same color marble. Okay, hope you understand that. And then the other question says, what probability that the marbles drawn will not be green? What probability that the marbles drawn will not be green? So how do we do that? We find probability that the marbles drawn will not be green. That means not being green will mean what? 1 minus probability of green. So find probability of not green, calculate it as 1 minus probability of green. Okay, so not green, what not means what? 1 minus probability of that event. For example, if the probability that it's going to rain today is 2 over 5, then the probability that it will not rain today will be 1 minus 2 over 5. Again, if the probability that it's going to rain today is 2 over 5, then probability that it will not rain today will be 1 minus 2 over 5, which is 3 over 5. So when you say probability of not, that means 1 minus probability of that very event. The probability of not green will be 1 minus probability of it being green. We'll say 1 minus probability of green, green. Green, green, the first green is 8 over 16, and the other green is 7 over 15. Why? Because first ball was not replaced. So we simplify this to get what? 23 over 30. Okay. Hope that is understood there. Now, the contingency table. So with the contingency table, let's say the North Cross High School had a total of 645 learners. They have a total of 645 learners. Right. 331 learners are boys. Nazamo grade 12 class organized a charity fund run where all the proceeds will be donated to the Red Cross Children's Hospital. In total, 602 learners attended the fun run, but 25 of the girls did not attend. All 654 learners at the school were given a raffle ticket, okay, which was drawn on the day of the fun run. Draw a contingency table and determine the probability that the winner of the raffle was 1 at the fun run, 2 a boy, given that the runner was not at the fun run. Okay, now we need to use the contingency table to do this. With the contingency table, what we do basically is we make sure when we draw our table, having all the headings that we talked about. So at the school, we have the boys, we have the girls, and we have the total. And then those who attended, who did attend and who didn't attend the fun run. and then we're going to have the total. So the bottom line is our total for every column must add up to the total at the end of the column. And then our total at the end at every row must add up to the total at the end of the row. So that is the basic idea with contingency table. Again, to answer this question, first enter the given data into the table. So the data we're giving, you need to enter into the table. So now those data that we're given are those I've highlighted in red. Okay. Now, first of all, the total of the total learner in the school is 654. There are 654 learners, and only so we'll have 654 here, and then 602, only 602 attended. So by attended, you put to 602. Okay, and then those who did not attend, they are what, 25. Okay, and then the total boys are 331. So we first enter those values we have. So knowing entering these values we have, so with these values, we can now complete the table. How do you complete the table? We know that when you add all the rows, it must add up to 331. And then when you add all the columns, you must get what? 602. So now here we have 654, and then here we have 331. So the first thing to do is to subtract this together to give us what? This 323. So 654 minus what? 331 will give us 323. So subtracting these two, we get 323. Okay, so we now have what? 223 here. So here is 25. So with this, you can find what? This amount. Because we know by the time we add this together, must add this total. So we subtract 25 from 323, you're going to get 298. So we have right about 298 here. So with 298 here, we can find the number of boys here who would attend. The number of boys who attend, we can get by subtracting the girls from what? Girls who attend from the total that attended. So subtracting this from the total that attended, we get 304, which is the number of the boys that attended. So the 27 we got by those who didn't attend, 52 didn't attend, 25. Subtracting these two will give you 52. Subtracting 654 from 602 will give you 52. So with 52 here and 25 here, these two must add up to 52. When I say 52 minus 25, that gives us 27. Like that, we complete our contingency table. And from there, we can answer the question. So what was the question? Which must, draw a contingency table and determine the probability that the winner for the raffle draw was at the fun run. What are the fun run? So now, what the probability is that the winner of the table of the raffle was at the fun run? So how do we do that? So how many people were at the fun run? So how many people were there? 602 did attend over the total. So the probability of choosing the winner at that one at the fun run will be 602. Meaning the total of those who attended over the total number of the students. So that gives the probability that the winner was at the fun run. So you get the number of those who are at the fun run over the total number of the whole learner. So the probability will be what? 6/2 over 6/54, and that will give you 92.05%. By multiplying it by 100, you get 92.05%. So that's the probability that the winner was at the fun run. Okay. And then the other question says that a boy, probably that is a boy, given that the winner was not at the fun run. Probably that is the boy, given that the winner was not at the fun run. So being a boy now, so that they were not at the fun run, that is what, 52. Given that they were not at the fun run, so how many people were not at the fun run? There are 52 of them. So probably that the winner is a boy, but the boy is not at the fun run. So how many boys are there? 27. That they were not, given that the winner was not at the fun run. So how many people were not at the fun run? 52. So the probability of getting a winner that is a boy that is not at the fun run will be 27 over 52. So our probability will be 27 over 52. I hope you do understand that. I hope you understand that. Okay. Now more exercise. Now Nadia did a survey where she asked a group of 85 learners whether they drink physical drink of fruit juice. Again, Nadia did a survey where she asked a group of 85 learners whether they drank physical drink of fruit juice. 42 said they drank both, 21 said they drank fruit juice only, and 12 learners said that they drank neither. Okay, what is the probability that a learner chosen at random drink only fizzy drinks? So to explain this, to do this, we will need to use what? A Venn diagram. Nadia did a survey where she asked a group of 85 learners, the total learner 85, whether drink either fizzy drink, fizzy cold drink, or fruit juice. So there you have fruit juice. Okay, now 42 said they drank both. So that means the 42 we placed at the center, there's an overlap. Therefore, we place the 42 at the center of the two circles. 21 said they drank fruit juice only. So 21 be placed by the fruit juice only, and 12 learners said they drank neither. So the drank neither will be outside the two circles. Now, what probably that the learners at random drink only physical drinks? So we draw our, first of all, we draw our Venn diagram, and then from there we can determine the probability. So 42 drank both. Okay, 42 drank both. 21 drank what? Only. 21 drank only fruit juice. Okay, now, and 12 drank neither. Okay, 12 drank what? Neither. So now, but everything must add up to 85. So by the time we add 21 plus 42 plus 12 plus this amount, which you don't know, must give us what? 85. So subtract 42, 21 and 12 from 85, you get what? 10. That means 10 only drank what? The cold drink. Okay, that means 10 only drank the cold drink. Okay, now the question now says, what probability that a learner chose at random drink only the fizzy cold drink? So how many drank fizzy cold drink? The cold drink, they are what? People drank cold drink, they are 10. How many? 85. Probability of choosing a learner that drank fizzy cold drink will be 10 over 85. 10 over 85. The probability of choosing a learner that drank fizzy cold drink. But 10 learners drank cold drinks out of a total of 85. And then the other question, what is are the event drinking fizzy cold drink and drinking fruit juice independent events? Are the event drinking cold drink and drinking fruit juice independent events? Yesterday we explained for independent events, the probability of if two events are independent, if the probability of A and B equals probability of A times B. Two events are independent if probability of A and B equals the probability of A times probability of B. So we're going to calculate probability of drinking cold drink and probability of drinking what? Fruit juice, multiply them together and see if it gives us probability of drinking both the intersection of both cold drink and the fruit juice. Okay, so now we're saying now that probability of cold drink is what? 10 over 85. Okay, and then probability of drinking cold drink is 10 over 42 over 85 10 over 85 multiplied by 21 over 85. So by the time you multiply it together, will it give us 42 over 85? So 42 over 85 is not equals to 52 over 85 times 63 over 85. So if you multiply 52 over 85 by 63 over 85, you will not get 42 over 85. So because the probability of A times probability of B does not equal to probability of A and B, then we say the events are not what? Independent. The events are not independent. So, and then we say this kind of question can also be answered using the contingency table. So using the contingency table, what do? We draw our table and try to complete everything that we're given, starting from the information we have. So 42 drank juice, 21 drank 21 not fizzy drinks. So, and then we have 21, we have 12 here. So we try to complete the table, knowing that the total number of people we have is 85. So with that, and then this is 33. So 33 minus 12 will give us 21, and then 85 minus 33 will give us 52. So 22 minus 12 will give us 10, and then 53 minus 21 will give us 42. So with this, we can use the contingency table. We can complete the contingency table from there we can now be able to calculate our probability. Okay, So we end our class this evening here, and then next week we carry on with counting principle. Okay, next week we carry on with counting principle. Thank you for attending the class, and then enjoy the rest of your day.